Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VIGNANA VJEC. I welcome you all to the lecture series on highway geometric design. So our topic of discussion for today will be cross-sectional elements. So these cross-sectional elements are nothing but if you take any particular highway or any particular road and you cut the road in the transverse direction. I'm not going to depth of the layers, I'm going to see only the top layers. So you are going to see some observe some layers of this category. So the first one, which is mentioned in green color or indicated in green color, so this is nothing but carriageway. The main portion of the road, predominantly it will be the carriageway. So the distance from here to here, it is nothing but carriageway. Okay, and apart from that, you have some extension on either sides, which are nothing but shoulders. So this particular value of carriageway plus shoulders on either side, that is nothing but roadway. This is represented as roadway, or it is also called as formation width. This is also called as formation width, the one which is indicated in violet color. Okay, and apart from that, you are also having road margins. So this is margin on either side. So this is margin over here, and this is margin over here. Okay, this is basically road boundary. This is road boundary. Road boundary is a point. Road boundary is a point and margin is a space or width. Okay, so this is roadway plus road margins on either side. This is very, very important, which is nothing but right of way, which is nothing but ROW, or it is also called as road land, which is also called as land width. So these are the values which you need to remember at any point of time. For example, this I'll explain in a very easy manner. So for example, if a person is given a weight of 50 or 60 kgs, the main important thing which is going to place the weight is nothing but he is going to place the entire weight on his head. So that is why somehow like that, every time the vehicle is trying to occupy the position on the carriageway itself. Okay, so that is how you can remember this is nothing but your carriageway. If something is given to you, you are going to place on your head exactly. So that is nothing but your carriageway. If beyond 50 kgs or 60 kgs, there are some more small weights that have been given to you, you try to keep that weights on your shoulders. So similarly, so this is your carriageway plus shoulders on either side. So up to this extent, you are going to call it as roadway. That is nothing but formation width. I repeat again. So this is your carriageway when you are placing your entire weight on your head, followed by when you are given with small weights, so that you are going to place on your shoulders. So up to this level, this is said to be the roadway. And still, if you are given some extra amount of weight, which is nothing but in length in direction, which is more in length, so then you try to extend your hands like this. So similarly, you are going to have here road margins. That is nothing but road margins will not have road. Okay, that is available for future. You can, that is purchased under the road itself. Okay, but it is open at present. So you can extend your road for future expansions. You can keep it empty like that. So that is why this is said to be the right of way, or also that is also called as road land or land width. Okay, and apart from that, you have next to road boundary, you are going to have building line over here. Okay, this is also building line, and the last one is nothing but control line. Okay, so these are the things which you need to remember. Okay, this is road boundary. Okay, up to road margins on either side. Okay, that is said to be the right of way, and these are nothing but building lines, and the distance between them is nothing but building distance between building lines, wherein which you should not have any construction carried out between these lines, and followed by control lines that are nothing but some extra offsets that are provided to the building lines on either side. So that is nothing but control line. So these are all the features. Apart from that, you are also going to see if there is any road which is going to have median, when you are going to have more than 4 lanes or from 4 lanes, that is also one parameter or one cross section element you are going to observe on this cross section elements. So the first one being carriageway. Okay, now we are going to see the regarding the carriageway. It is a pathway, or it is a part of the road which is predominantly used for the vehicle for the movement purpose. So, and it is also going to take the vehicular loading. So that is what the definition of carriageway. Okay, it might be of CC road or it might be BC road. CC is nothing but cement concrete road, and BC is nothing but bituminous concrete road. And this width of the carriageway is going to depend upon the width of the traffic lane and number of lanes. First, you need to decide how many number of lanes are to be provided. Again, that number of lanes is going to depend upon the predicted traffic, that is nothing but estimated traffic, and also your desired level of service. So that is how you decide the number of lanes in the first condition. And how much width of the lane each lane should be provided, that again depends upon the width of the vehicle and lateral clearance. That is what regarding the carriageway. It is mainly the portion of the road which is predominantly used by the vehicle for the movement and is going to carry the vehicular loading. It might be any type of the road, either it might be a black topped road or white topping road. We are not bothered about the type of the road. Okay, we are going only to see the width of the carriageway, how many number of lanes is it present, and what is the width of the each and every lane. And again, the width of the each lane is going to be decided by width of the standard vehicle or width of the vehicle, along with how much of the lateral clearance you need to provide on either side. So this is regarding the carriageway. So you can remember this as to your carriageway. And based on that, you are going to have some important or standard values which you need to remember again for your problem solving. So one is nothing but a class of road, and next one is width of the carriageway in meters. The first one is nothing but single lane road. You are going to have 3.75 meters. Very important. Single lane carriageway is going to have 3.75 meters, and double lane carriageway is going to have 7 meters. Okay, and double lane carriageway with riser curbs, you are going to have 7.5 meters. When you are going to have riser caps, you cannot go onto the shoulders. You don't have any extra space for emergency conditions and all. So for which you are going to provide 0.5 meter. That is nothing but 0.25 meter extra on either side. So that is why you are going to have 0.5 meters extra in terms of 2-lane road with riser curbs. But when you don't have riser curbs, it is nothing but only 7 meters. Okay, and intermediate carriageway, it is predominantly you can see this in village roads where you don't have a single lane road and you don't have either a 2-lane road. You are going to have an intermediate carriageway, that is nothing but 5.5 meters. And beyond number of 2 lanes, you have to provide a width of 3.5 meters for each and every lane. That is nothing but 3.5 meters per lane. So once again, I repeat the values. For single lane carriageway, it is 3.75 meters, and for double lane carriageway, it is 7 meters without riser curbs, and it is 7.5 meters with riser curbs, along with an intermediate carriageway with a width of 5.5 meters, and more than 2 number of lanes, you have to provide a width of 3.5 meters per lane. So this is regarding the carriageway. And this is single lane road. Okay, so single lane road, and it is 2-lane road. Okay. So this is the vehicle which I am having over here. I'll take the vehicle to be, width of the vehicle to be standard width is exactly 2.44 meters, but for rounded off purpose, I'll take it as 2.5 meters. So that is the width of the vehicle which I'm going to have over here, and so therefore the center portion will be 2.5 meters. So the other portion over here, this and this will be your extra. So that is nothing but the standard width of the carriageway is nothing but 3.75 meters. Okay, so you have to divide this 3.75 meters. 2.5 meters from 3.75 meters. Whatever you are going to get, you have to provide clearance on either side. So 3.75 minus 2.5, which is nothing but 1.25 meters. And that 1.25 meters you have to provide on either side. It will be 0.625. Okay, so this is regarding the single lane road. Okay, and coming to the 2-lane road, we will discuss this in terms of without riser curbs, which is nothing but a width of 7 meters. So I'm going to have a 7 meters width of the carriageway, over which I'm going to have 2 vehicles, adjacent to each other. Spaced with an lateral, we are having a central spacing of 1 meter on either side. So 5 plus 1, 6. So you are going to have 0.5 lateral clearance over here, and the other 0.5 lateral clearance over here. So this is 0.5, the lateral clearance, and this is the central clearance, and this is nothing but 0.5 meters. So this is how you have to distribute the width of the carriageway based on your width of the vehicle. And next, coming to the next cross section element, which is nothing but the shoulder. Okay, shoulder is nothing but adjacent to your carriageway. The purpose of this is nothing but it is provided along the road edge. So you have a road over here. Okay, and you are going to provide at the edge portion, at the edge of the road, as an emergency lane for vehicles. It is going to be used for emergency lane, or sometimes it can be also used for movement whenever possible. It also acts as a service lane for vehicles that have broke down. When the vehicles are in breakdown condition, so they can park their vehicles for some point of time in the shoulders. So that is regarding the shoulders. And next one definition is nothing but roadway. Roadway is nothing but it is a summation of carriageway which is the central portion, plus shoulders on either side. Okay, so that value is going to be where your roadway value. Roadway is nothing but carriageway plus shoulder one side and shoulder another side, which is nothing but 2 shoulders. Okay, here in terms of the shoulders can be again anything. It might be a treated shoulder, or it might be earthen shoulder, or it is nothing but paved shoulder. Okay, it can be of any other category. You can have some paved shoulders. Either if it is a BT road, you will have BT shoulders, or sometimes it will be treated earthen shoulders or untreated earthen shoulders. Okay, and that is regarding roadway and shoulders. Coming to the right of way, again right of way is nothing but roadway plus road margins. You have come to a value of road margins on either side. So roadway plus 2 road margins, that is nothing but this is going to get the value of right of way. Okay, so again if you look into the definition, is the total area of land. It is not actually width, it is again area. Okay, we are speaking only in terms of the length. So the total area of the land acquired for road along its alignment. So that is the government is going to purchase extra amount of land for future expansions. So that is why it is said to be right of way. The width of the land, acquired land for right of way, is known as, it is also called as land width or road land, and it depends upon the importance of road and possible future development. So you are not going to have as much as right of way. But there is a limit for right of way. It is going to depend upon the importance of the road. If it is a national highway and state highway, you are going to have some amount of right of way, or if it is major district road, other district roads, you are going to have some lesser value of right of way. It also depends upon your possible future developments. And the land width is governed by, again it is also going to be governed by some of the features like formation width, embankment height, sides, slopes of cutting and embankment, side distances. So these are the factors which are having an impact on right of way. So this is one figure where you can see all the cross-section elements over here. So this is nothing but on the left side I am going to have this carriageway. It is nothing but 1-lane carriageway, and it is nothing but 2-lane. So this kind of road, you are having 2-lane on left side, you are also going to have 2-lane. You have other 2-lane on the other side. This is said to be 4-lane divided carriageway. You are going to have a median over here. As you have a median over here, this is said to be 4-lane divided carriageway. If it is only on one side of the road, that is nothing but 2-lane carriageway. That is nothing but you are going to have 2-lane, okay, like this. At the you are going to have center line like this dotted. So if this is only like this, so this is said to be 2-lane road. So this is 1 lane and this is 1 lane. So that is said to be 2-lane carriageway. If the movement of the traffic is nothing but in this direction in both the lanes, so that is said to be your 2-lane one-way traffic. 2-lane one-way traffic. Okay, but you have 2-lane road like this. Okay, and you have 1 lane of the road moving in this direction, other lane traffic is moving in this opposite direction. That is said to be 2-lane traffic, 2-way carriageway. 2-way carriageway, 2-lane traffic. So that is regarding 2-lane carriageway. But this is nothing but 4-lane divided carriageway. Whenever you are going to have median, you are going to be addressed that as divided carriageway. If it is 2-lane and 2-lane other side, so that is said to be 4-lane divided carriageway. If you have 3 plus 3, then that is nothing but 6-lane divided carriageway. Divided is something which you use when you have a median over here. And you can see this portion of this carriageway which is provided, extension to the carriageway, which is nothing but shoulders. You can see the difference between carriageway over here and shoulders. Okay, the shoulders here provided in this case is not the same material which is being used for the carriageway. As I told you, that can be paved or unpaved, or it can be earthen shoulders, or it can be somewhat inferior quality when compared to that of carriageway. Similarly, you have a shoulders here also. Okay, so and you can see a marking over here. So there will be somewhere extension. Okay, beyond shoulders you are going to have road margins. Okay, and from this road margin on one side and the road margins on other side. Okay, from this to this, the entire portion is said to be the right of way. Okay, similarly, if it is required, you are going to have some guardrails on either side in terms of the highways. Okay, and this is the median, again you are going to have at the central portion. That the median purpose is given over here. Median is provided between 2 sets of traffic lane. So this is nothing but one set of traffic lane moving forward, and this is another set of traffic lane which are coming outside or moving in this direction. So to divide the traffic moving in opposite direction, that is a very first and foremost feature regarding the median. And it is also going to avoid the head-on collision because the vehicles are coming in opposite to each other. So the main purpose is nothing but to avoid the head-on collision. And item also, it is, as the median is going to be occupied with some amount of plantation, it is also avoid the glare effect of the vehicles moving in the opposite direction. So coming to right of way, so we have discussed what is the value of a carriageway which need to be incorporated for different number of lanes. Similarly, we have to remember some set of right of way values for different kinds of roads. So this is nothing but expressways and national highways, state highways, major district roads, ODR and VR. Okay, so there is no particular values of formation way, but you have to remember the values for right of way. And this is again in plain terrain and rolling terrain. So this terrain, you have to look back into the factors controlling the geometric design, the previous lecture, where I have discussed regarding the topography of any area, which will be divided into 4 terrains. The first will be plain terrain, followed by the rolling terrain. So in terms of plain and rolling terrain, okay, you have to have a right of way of 90 meters in terms of open area. So if the area is open area where you don't have any built up area, or it is somewhere outside the cities, you need to have a width of 90 meters. And if it is a built up area, there is no particular value over here. Okay. Similarly, for national highway, state highway, you are going to have 45 meters. All these values are in meters, 45 meters. But in built up areas, you are going to have 30 meters. So this is regarding plain and rolling terrain, open area and built up area. You just look into these values over here. And mountainous and steep terrain, you have to only see the observation when you move to higher terrains. That is nothing but when you are switching from rolling terrain to steeper terrain like mountainous and steep terrain, you will be having reduced values of right of way. And again the same way, just like the design speed, when you move from top to bottom, okay, like when you are coming from expressways to village roads, you are going to have reduced speed. Similarly, you are also going to have reduced right of way over here. Okay. But you can see here, even in village roads, even the width of the carriageway is only 5.5 meters, as we have discussed that, which will be an intermediate carriageway. But still we have 12 meters, so which is nothing but almost more than double. So this is what the right of way is intended for. You have to go for future expansions, so for which you cannot search for land at that point of time. So you have to go for purchasing at the beginning itself. So but you can see that values are going to be very, very higher, 45 meters. Okay, in terms of national highways and state highways. And we are also going to see what are the different differences. Another cross section element, one which is nothing but the gradient. So gradient is nothing but if you take any road like this is the central portion of the road. Okay, so this is some camber provided over here. So this is the road which is moving in this direction. So if you see from this point to this point like this is the one point and this is the another point. Okay, so when you are moving along the length of the road, the definition is nothing but the slope provided along the length of the road is said to be the gradient. Okay, so this you cannot see in the initial figure. Okay, so this is again we cannot see gradient in this, but this will be perpendicular to this over here. Okay, but you can see over here, so this is nothing but gradient. So when you are moving from point A to point B along the length of the road, it might be like you can be at the same level, or it can be you can end up with a higher level or lower level when compared to that of point A when coming to point B. So if you are at a higher level, that is nothing but an ascending gradient. Okay, if that is point B is nothing but somewhere over here, so then that will be a descending gradient over here. Okay, but the same thing, this might be an ascending gradient in forward direction, and this will be an descending gradient. If this is your point A and this is your point B, again you have come down to the a different level when compared to that of point A in the reverse condition. So it depends upon the direction of travel, whether it is an ascending gradient or descending gradient. So that is about the gradient, which is given by the symbol G. Okay, and it is expressed in vertical to horizontal, because that is a slope over here. So that should be expressed in vertical to horizontal. Always the value of gradient should be expressed as 1 in n. So this value of vertical should be always 1 meter. This is a slope, will not have units for this, and the value for vertical rise or fall should be taken as 1 meter. And this, how much is the distance you have traveled in the horizontal direction to attain a rise of 1 meter or a fall of 1 meter. So that is said to be n is the horizontal distance. For example, let me assume that this is 1 meter rise or 1 meter fall. So I am going in this direction. So this is my point A and this is my point B. So I have attained a value of 1 meter rise when I have went to point B, and if I have traveled it 100 meters to attain that 1 meter rise, so that is said to be 1 in 100. So now my gradient is nothing but 1 in 100. So this is represented like this, 1 in 100. Okay, so this is capital N. Okay, both are in meters. Okay. And so this is the gradient coming to this. Any value is given for you. You have to express that always in 1. For example, there is a value of 50 meters. Okay, I have traveled 50 meters to attain a value of 0.5 meters. You have to convert that in 1 in n. I have told you that this is a vertical and this is a horizontal. But whereas you are given with a value of 0.5 over here, you have to convert that for 1. So you have to divide this over here with 0.5 and you have to divide with 0.5 over here. So this will be 1 meter. And this will be 50 divided by 0.5 is nothing but 100 meter. So this is equivalent to again 1 in 100. Okay, this again it will be represented as in percentage. So that is nothing but 1%. Okay, if you want to compare the gradients, two different types of gradients. Okay, so in this condition I have went for a distance, horizontal distance of 50 meters and I have a rise of 1 meter. Okay, so this is one kind of gradient 1. Okay, another gradient I will mark in a different color. So I have traveled 100 meters, so 50 plus 50, which is nothing but 100 meters, and still I have a rise of 1 meter itself. So this is one kind of gradient, this is another kind of gradient. So by seeing itself, you can tell that gradient 1 is steeper gradient and gradient 2 is nothing but mild gradient. Okay, so this is 1 in 50. This is gradient 1, which is 1 in 50, and gradient 2, which is nothing but 1 in 100. Okay, or else if you have a confusion, you convert that into percentage. 1 by 100 into 100, it is nothing but 1%, but whereby 1 by 50 into 100, it is nothing but 2%. Either you can express this as 1 in n or small n percentage. Small n is nothing but 1% or 2%. The gradient is nothing but the slope along the length of the road. It is nothing but gradient. And it can be expressed as 1 in n, where 1 is 1 meter rise or 1 meter fall for a horizontal distance of n meters. It can also be expressed as small n percentage. Okay, and one thing which you need to remember over here is nothing but the gradient is not going to be decided by the highway designer. Okay, it is going to be predominantly influenced by the topography. If your topography is a plain terrain, then the gradient will be some lesser values. If your terrain is nothing but mountainous or steepy terrains, then you have to end up with some different gradient values and all. So we are not introducing purposefully any gradient in any topography. Okay, it is going to depend upon the topographical conditions. Okay, so this is regarding the gradient. And these are some of the different types of gradients over here. So you have different types of gradients over here: ruling gradient, limiting gradient, or exceptional gradient. In terms of plain terrain, you have 3.3%. Okay, and limiting gradient for planar rolling terrain is 5% and 6.7%. Or you can remember in this order. So plain terrain or rolling terrain, mountainous terrain, and this is steeper terrain. So for rolling terrain, you have 3.3, 5, 6. Okay, and this 5 will be shifting over here and this 6 will be shifting over here, and you are getting some extra another value 7 over here. Okay, and this 6 will be shifted over here and this 7 will be shifted over here, and you are going to get an extra value of 8 over here. So you have to remember the type of the terrain: planar rolling terrain, mountainous terrain, steep terrain. In terms of ruling gradient, ruling gradient is the minimum gradient that is possible on a highway section. Okay, which will not involve in reducing the speed of the vehicle. So that such a kind of gradient is said to be the ruling gradient. So you have 3.3% for plain and rolling terrain, followed by 5, 6, and again this 5 will be shifted over here, 5, 6, 7, and followed by 6.778. So these are the values, different types of gradients. And next to the last cross-section element, what you can see over here is nothing but the camber. Previously we have been looking at gradient, which is nothing but the slope along the length of the road, so which is going to be decided by the topographical features and not at the virtue of the highway designer. Okay, but whereas the camber is going to depend upon the type of the rainfall. So it is nothing but it is provided in the lateral direction or in the transverse direction. The slope provided in the transverse direction to the road surface, which is very, very important to drain off the rainwater from the road surface. So that is said to be the camber. It is going to depend upon the type of pavement surface and the amount of rainfall. So the camber, as I discussed just now, it is nothing but the purpose is nothing but to drain off the rainwater. So it is going to depend upon the type of the payment and as well as the amount of the rainfall. Okay, so higher the rainfall, higher should be the camber. Lower the rainfall, lower should be the camber. Okay, because high rainfall will always need higher amount of camber. At the same time, superior the quality of the roads, very important. This can be an objective question also. Superior quality of the roads, lesser the camber. Okay, because the superior quality of the roads will have a concrete portion and there will be immediate drain of the water. But whereas if you go to the inferior quality of the roads and all, you are going to have some more amount of infiltration, for which you need to provide higher amount of camber. So this is what the table which you need to remember for different camber values. Type of the road surface, the first one is CC road and next one is thin bituminous surface, and here CC road again combined with thick bituminous roads, thin bituminous roads, waterborne macadam and earthen roads. Again, just now I mentioned low rainfall and high rainfall. High rainfall will have higher value because this is 1.7%, this is 2%. You don't get confused with 50 and 60. And the wonderful way of remembering this table is nothing but you come from right to left, from top to bottom. 60 to 50, 50 to 40, 40 to 33, 33 to 25. You just repeat for twice, 60 to 50, 50 to 40, 40 to 33, 33 to 25. You are going to remember these values. Remember that you are moving from low rainfall to high rainfall and you are coming from superior quality of the roads to the inferior quality of the roads. Okay, if you can remember that values, you convert that into small n percentage, where I have mentioned that values in 1 in n. Okay, these values of camber are very important in problem solving. Okay, so that is clear over here. Superior the quality of the road, so cement concrete road is the superior quality of the roads, so we have 2% over here. But if you go to the bottom roads, we are going to have 4 and 3% for earthen roads. So that is why superior quality of the roads, you are going to have lesser values of the camber, but whereas if you go to the bottom side, you are going to have higher amount of camber. Okay, and at the same time low rainfall is going to have less amount of camber and high rainfall is going to have higher amount of camber. The way how you provide the camber in a road is very important. You can provide by different ways. One is nothing but you can introduce a parabolic camber over here, and it is a straight line camber, and it is a combination of straight line and parabolic camber. So I'll just look into this straight line camber over here. So this nothing but central portion, just let it be Y. So the rise of the crown portion, the central portion is nothing but the crown, and this is nothing but the edge portion. So let me assume that 1 in n. Okay, here also the camber is expressed as 1 in n. Okay, or small n percentage, just like the values mentioned over here. The camber also can be expressed as 1 in n or small n percentage. So I'll take this one value for n meters along the, perpendicular to the direction of the road. So in the transverse direction, the slope is 1 in n. So for a width of W, by 2, we are taking only on half side. So for a width of W by 2, which is nothing but W by 2 over here, that is nothing but this is a horizontal and this is vertical. Okay, we are looking for what is the height of the crown portion. So this is my pi value. I repeat over here. So for 1 meter horizontal distance, how much I am going down? Okay, for 1 meter vertical distance, how much I am going in the horizontal direction? So that is 1 in n. And for a width of W by 2, what is the value of I required? So if you go for cross multiplication, so W by 2 is equal to Y into n. So I am looking for Y is equal to W by 2n. This is the value of Y over here, W by 2n. Width is nothing but the width of the carriage. Okay, that is in terms of the straight line camber or triangular profile. Okay, but whereas if you look into this parabolic profile, there is a small derivation over here. So that is nothing but 2x square by nw. Okay, we are not going deep into the derivation of this height of the crown, okay, or the rise of the crown for a camber. So y is equal to 2x square by nw. But we'll try to see what is the value at the central portion over here. Okay, this is anywhere you can obtain the value of y value at the rise of the road at any point, but I'm again interested to calculate the value of y at the central portion. If y is there, I need to calculate x is nothing but in the horizontal direction and y is nothing but in the bottom direction. So again, if I substitute y is equal to, I need to get the value of y similar to that of triangular profile. X should be again b by 2, x should be w by 2. So 2 into w by 2 whole square, divided by nw. So that is nothing but 2 into w square by 4nw. So here w gets cancelled. So 2 gets cancelled. So that is nothing but y is equal to w by 2n. W by 2n. So it means nothing but y is equal to W by 2n for parabolic profile. Okay. So irrespective of the type of the profile you are providing, either it might be a triangular profile or parabolic profile, your rise of the central portion is not going to change. Okay, it is only the way how you are introducing your camber is a different way, but the rise of the central portion will be same at the central portion, and it will not be the same at the 1/3 portion. It will not be, if you check the values, you can work it out at the 1/4 road at 1/4 distance or b by 4 distance. It will not have the same value. It is only same at the central location. Okay, so we'll look into the small problems over here. So if there is a rise of 1.5 meter in the level of the road in a stretch of 150 meters. So this 150 meters is nothing but n meters horizontal distance. So I've traveled 150 meters in the horizontal direction, and there is a rise of 1.5 meter. So this is what they are asking, and you have to tell, and we are asked to calculate the gradient over here. I've told you like 150 meters for I'm going to have a rise of 1.5 meters. Again, I need to have a vertical as only 1 meter. So I'm dividing this with 1.5, and this also I'm dividing with 1.5. 1.5 is nothing but 3 by 2. So this 3 will be over here and 2 will be over here. So 3 5s are 15. So which is nothing but 100. So the same, it is nothing but again 1%. The same, the gradient is nothing but 1%. They'll confuse you by giving different types of values, but just it is an easy conversion where you have to make the value of y or vertical value has to be 1. Okay, if the ruling gradient of a particular area is 1 in 20, what is the camber value? So there is a very important relation which you need to remember between gradient and camber. So the relation between ruling gradient and camber at any particular value that holds good is G is equal to 2C. Okay, as it is 1 in 20, you just suddenly don't put it as 1 in 10. You are asked suddenly you are just asked to calculate over here. So G is nothing but 1 in 20. Okay, that is nothing but 2 times of the camber. If you calculate the camber, C is equal to 1 in 40. So this is what the value of camber over here. So the relation is very important here. The between gradient and camber, G is equal to 2C. And again, the last question for today will be a BC road, a bituminous concrete road with the 2 lanes need to be constructed in a low rainfall area. Calculate the rise of the crown. So we are asked to calculate the rise of the crown portion when with respect to the edges by means of both parabolic profile and triangular profile. So one is nothing but parabolic profile and next one is triangular profile. We'll look into the triangular profile over here, and we'll look into the parabolic profile over here. Okay. So BC road, that is nothing but bituminous concrete road. If it is not mentioned, you can let us assume it has to be thin bituminous road, and 2 lane. Here nothing is being given over here, so everything you have to take from the data what has been given in the sentence. 2 lane road. So 2 lane road is nothing but 7 meters. Width of the carriageway is nothing but 7 meters. Of course, we have to assume it to be without riser curbs. Okay, so therefore B or W is equal to 7 meters. Okay, and it is a low rainfall area. So low rainfall area, if you just look into the table, 1 in 60, 1 in 50, 1 in 50, 1 in 40. So we are in the second row. That is nothing but low rainfall area because it has been mentioned as low rainfall area. So therefore your camber will be is equal to 1 in 50. So this is like that. You have to recall the values based on the type of the rainfall and based on the type of the road. Here nothing is given, just type of the road is given. Low rainfall it has been mentioned, and 2 lanes it has been mentioned. From that you need to get the values of everything. So with this you can get the value of formula y is equal to y is equal to W by 2n. Y is equal to W by 2n. So your width of the carriageway is nothing but 7 meters. 2 into 50. Okay. From that you can calculate. You will get some value over here. So that is nothing but 7 divided by 100. 0.07 meters. So that will be 7 centimeters. The value over here will be 7 centimeters. Similarly, you can calculate the value from here. Y is equal to 2x square by NW. You will end up with the same value of 7 centimeters. Why? Because we have discussed that irrespective of the type of the profile what we have been providing, okay, the rise of the crown portion and the central portion will be same in terms of triangular profile and parabolic profile. So you'll get the value of 7 centimeters. So this is what we have been asked to calculate. So this is 7 centimeters and this is 7 centimeters. Okay. So I'll end the discussion over here for today. So I greatly appreciate the resources from where I have collected this slides and all and images. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.